All right, everyone, get ready for a deep dive today into DNS and DHCP, two technologies that you're probably already working with if you're listening to this.
Yeah, I'd say so.
You know they're essential for any network, but stick with us on this one because I think we're going to go a little bit deeper than maybe you've gone before.
Absolutely.
We've got some great course materials and even your practical assignment to help us out with this.
Oh, perfect.
So we're going to try to not only just clarify these concepts, but uncover some interesting details, some connections, and help you really grasp how these systems work together.
Sounds good.
So let's start with DNS. This is often explained as like the internet's phone book, translating those human-friendly domain names like, google.com into those IP addresses that computers can actually use. But have you ever thought about what would happen if that phone book had a few pages ripped out?
Uh, that's an interesting way to put it, yeah. Because if you only rely on DNS caching, which we'll discuss later, you might run into some problems. Because your computer might remember an old IP address, for example. And that could lead to some connectivity issues, or even worse, redirect you to some malicious website. It's a bit like trying to call a friend but accidentally calling a complete stranger because you still have their old number in your phone.
Yeah, and that's a perfect analogy. So it's not just about translating these names, it's about making sure that translation is accurate and up to date.
Exactly, and that's where the hierarchical structure of DNS comes in. It's not just one giant phone book, but more like a system with different levels of authority.
Right, like a family tree with the 13 root servers, the internet grandparents, as you
Right.
will, at the very top, manned by ICANN. Then you have your top-level domains like .com, .nl, the internet parents, managed by organizations like SIDN, for example, over there in the Netherlands.
Right, exactly. And that's important for security and resilience. If one DNS server goes down, there are others that can take over. So it's a real distributed system.
Okay, so it's designed to be robust, to prevent those single points of failure. But what about within our own networks, specifically Active Directory? You mentioned DNS plays a critical role there, too.
It's even more critical, I would say. In an Active Directory environment, your DNS is not about reaching websites on the public internet, but more about making sure that all the computers and services within your domain can find each other.
So it's like having a separate internal phone book for our own little network, right?
Exactly. And you have different record types, hostess records for computers and SRV records for services. For example, you have LDAP.TCP, and that is essential for Active Directory to function.
So without DNS, Active Directory would essentially be broken.
Absolutely, it's the glue that holds everything together. And remember that your domain controller always acts as a DNS server. They are inseparable for a reason.
Okay, starting to grasp the magnitude of DNS here. But before we get too lost in the world of domain names, let's switch gears for a second and talk about DHCP. Now, I know DHCP is responsible for assigning IP addresses to devices. But why is that such a big deal? I mean, couldn't devices just choose an address themselves?
Imagine a world where everybody in your office shows up one morning and decides to sit at the same desk. Chaos, right. That's what would happen without DHCP. IP addresses need to be unique, just like those office desks, to ensure that devices can communicate with each other without any conflict.
So DHCP is like the office manager, making sure everyone has their designated workspace.
Exactly. Maintaining order, and it also provides other essential information, such as subnet mask, default gateway, and the addresses of your DNS servers.
Ah, that's how those devices know where to find the phone book in the first place. It all comes from DHCP. It's really a beautifully synchronized system, isn't it?
Absolutely. DHCP and DNS work hand in hand to make sure you have a seamless network experience.
All right, starting to see the bigger picture here. So DHCP ensures that our devices can connect to the network. DNS helps those devices find and talk to each other. And Active Directory relies on DNS for its very existence. But can we see how this actually plays out in a real scenario?
Sure, let's say you have a new printer in your office. DHCP will assign it an IP address, like 192.168.101.110. Now, when you want to print something, you don't need to remember that IP address, but you could just use the name Printer01.
And behind the scenes, DNS is working its magic, translating that name, Printer01, into that actual IP address, 192.168.100.110. It's like having a friendly receptionist that knows where to direct you.
Precisely. But imagine that DNS record is outdated because of, for example, caching issues.
Yeah.
You might end up trying to print to a completely different device, or even worse, a non-existent one.
That's a great point. Really highlights how crucial it is to have reliable and up-to-date DNS records, especially in an environment where connectivity is paramount.
Right. Exactly. And speaking of reliability, let's talk a little bit more about DNS caching. It's a mechanism that could be both a blessing and a curse.
Okay, I'm intrigued. Let's unravel the mysteries of DNS caching and see what pitfalls we need to be aware of.
Welcome back. So we've been talking about DNS caching, how it makes things faster, remembering IP addresses so your computer doesn't have to look them up every single time.
Right, exactly.
But what happens when that information is wrong?
That's what I'm curious about. It sounds like DNS caching, while helpful in some ways, could actually cause some problems if that information is outdated.
Exactly. Let's say, for example, a website changes its IP address. Your computer might still try to connect to that old address, leading to a site can't be reached error.
So it's kind of like using an old map where the roads have changed. You might end up getting lost.
Exactly. And it's not just for websites. This can happen with any type of DNS record. For example, imagine trying to connect to a shared network drive. If it's been moved to a new server, your cached record might point to that old location.
Yeah, okay, I'm starting to see the potential downsides here. But isn't there a way to prevent these caching mishaps?
There are. And you might remember we talked about the time to live, or TTL. That value determines how long a record can stay in a cache.
Right.
And shorter TTLs mean that the information will be refreshed more frequently.
So it's a trade-off between speed and accuracy.
Exactly.
Shorter TTLs, you have to do more lookups, might slow things down a bit, but it also ensures that information is up to date.
Exactly. It's a delicate balance.
Right.
But caching isn't the only potential security concern when it comes to DNS. Remember that vast global network? That makes it a prime target for attackers.
Yeah, now that you mention it, I was just thinking about those 13 root servers. What if someone were to compromise those? Wouldn't that be catastrophic?
It would be incredibly disruptive. But thankfully, those servers are incredibly secure. They're protected by multiple layers of security. But attacks can happen at different levels. One common technique is called DNS spoofing, or DNS cache poisoning.
DNS spoofing, that sounds kind of ominous. What does that involve?
Well, imagine an attacker manages to slip a fake DNS record into a server's cache. Now, when your computer tries to reach, say, your bank's website, it might be redirected to a malicious site controlled by the attacker.
So it's like someone's tampering with the phone book, changing the number so you end up calling the wrong place?
Exactly.
Yeah.
Attackers can use this technique to steal sensitive information, install malware, or even redirect traffic to their own servers for financial gain.
Okay, so that is seriously concerning. Are there any ways to protect ourselves from these DNS spoofing attacks?
There are. One important measure is called DNS SEC, or DNS Security Extensions. This adds digital signatures to DNS records, verifying their authenticity.
So it's like a digital seal of approval, guaranteeing that the information is actually coming from a trusted source.
Exactly. Another layer of protection is using secure DNS resolvers. These encrypt the communication between your computer and the DNS server, making it much harder for attackers to intercept and manipulate those queries.
So it's like having a secure tunnel for your DNS requests, protecting them from those prying eyes. Yeah, that makes sense. But all this talk about security makes me wonder, have there been any real-world examples of major DNS outages or attacks?
There have been a few notable incidents. One example is back in 2016. A massive DDoS attack targeted DIN, a major DNS provider. This caused widespread outages across many popular websites and services.
Yeah, I vaguely remember that. It felt like the internet was on the brink of collapse.
It was a stark reminder of how much we rely on DNS.
Yeah.
But while the security of the system has improved since then, new threats are constantly emerging.
So vigilance is key. But let's shift our focus back to our own networks for a moment. Let's dive deeper into the world of DHCP configuration.
Sounds good. You might remember we talked about DHCP scopes earlier. They're essential for organizing your network and making sure that your devices get the correct IP addresses.
Right, it's like dividing a library into different sections.
Exactly. You can create separate scopes for different types of devices, servers, workstations, guest devices. This allows you to apply different policies and settings to each group.
So it's not just about handing out IP addresses randomly, it's about having that structure and assigning those addresses in a controlled manner.
Precisely. And this is where DHCP options come into play. Think of them as additional instructions attached to a DHCP request.
Oh.
Can provide more specific configuration details to the device.
Can you give me an example of how these options work in practice?
Sure. Let's say you want to configure a specific default gateway for all devices in a particular scope. You can set a DHCP option that tells those devices to use that gateway whenever they need to access resources outside their local network.
So it's like providing a map with a designated exit route for those devices leaving their designated area.
Exactly. And these options can be used to configure all sorts of settings, from DNS server addresses to time servers.
Wow, this is all starting to make so much sense now. But with all this customization and complexity, I can't help but wonder what happens when things go wrong? How do we troubleshoot these DHCP gremlins when they inevitably pop up?
That's a great question, and it's one we'll tackle head on in the final part of your deep dive.
Okay, I'm ready for the challenge. Let's crack these DHCP cases wide open.
All right, welcome back, network detectives. We've journeyed through all the intricacies of DNS and DHCP, but now it's time to really put our knowledge to the test. We're going to be tackling those real-world DHCP troubleshooting scenarios, those moments when the network just throws us a curveball.
I like that. Network hooting it. I like it.
Yeah.
We have the clues, the tools, and the expertise to solve these DHCP cases.
All right, so let's dive into a scenario that I'm sure we've all encountered at some point. You sit down at your computer, you're ready to start your day, but oh no, there's no internet access. Your Wi-Fi signal seems strong, everything seems connected, but you're stranded on this digital island.
Right.
So where do we even begin to unravel this mystery? Well, I think our first suspect is always the IP address. If a device isn't getting a valid IP address from DHCP, it's like having the wrong address on a package. It's simply not going to reach its destination.
Right. It's like trying to call someone, but you dialed the wrong number. How do we even check if that's the case?
Well, we need to examine the device's network settings. On most systems, you can simply run the command ipconfig, and that will reveal the IP address. And if you see an address that's in the 169.254.x.x range, that's a telltale sign that DHCP isn't working as it should.
Right. The infamous APA-PA address, automatic private IP addressing.
Yeah.
The network's equivalent of just a shrug emoji. It's basically saying, I have no idea what your real address is, so I'm just going to give you this temporary one.
Exactly. And with an APA-PA address, you can only communicate with other devices on your local network. So no internet, no access to any external resources.
Right. So our next step then would be to figure out why the device isn't getting a proper address from DHCP. So let's put on our detective hats here. What are some common culprits in this DHCP mystery?
Okay, so the first thing we need to check is the DHCP server itself. Is it actually up and running? It might sound obvious, but sometimes a simple restart can resolve the issue, just like rebooting your computer when it's acting up.
Right. Turn it off and on again. That always seems to work. But let's assume that the DHCP server is alive and well. What would be our next line of inquiry?
Okay, we need to check if that DHCP server is authorized to operate within the Active Directory domain. Only authorized servers should be allowed to hand out IP addresses.
Right. Rogue DHCP servers, they can cause all sorts of havoc on the network. So if the server isn't authorized, that could definitely be why our device isn't getting a proper address. What else should we consider?
Well, we should also check the DHCP scope. If the scope is exhausted, meaning that all available IP addresses have already been leased out, then new devices won't be able to obtain an address.
Right. It's like a hotel with no vacancies. You just can't check in. You have to make sure that the scope is large enough to accommodate all the devices on the network.
Exactly. But sometimes the problem isn't with the server or the scope, but actually the connection between the device and the server.
Oh, you mean like a physical cable issue? Or a misconfigured switch port? Yeah, that could definitely disrupt communication.
Absolutely, like trying to make a phone call with a broken phone line.
Right, the message just can't get through, so we need to make sure that all the physical infrastructure is sound, that the network configuration is correct. Any other potential roadblocks that we should be aware of?
Well, sometimes a firewall can also be blocking DHCP traffic.
So we might need to adjust the firewall settings to allow those DHCP requests to actually pass through.
Exactly. And of course, we always need to watch out for red herrings, those seemingly obvious clues that can lead us astray. So it's important to gather all the facts, test all our assumptions, and be really methodical.
Just like a good detective, observant, patient, and willing to eliminate all the possibilities one by one.
Precisely. And we're not alone in this. There are some powerful tools that can help us. For example, network monitoring tools can provide very valuable insights into DHCP traffic, showing us all those patterns, errors, anomalies that can help us pinpoint the root cause.
Right. It's like having a magnifying glass for our network.
Exactly. And I would also say never underestimate good documentation. A well-maintained network diagram can really be a lifesaver, showing all the connections between devices, helping us trace the flow of traffic.
This has been an incredibly insightful deep dive. We've gone from understanding just the very basics of DNS and DHCP to now troubleshooting these really complex scenarios. So what would you say is the most important lesson that our listeners should take away from all of this?
I think the key takeaway takeaway is that these seemingly invisible systems are really the backbone of our digital world. They're essential for everything, from browsing the web to just accessing shared files on our local networks.
Right, and while they usually just work flawlessly in the background, understanding how they operate and knowing how to troubleshoot them can save you a lot of time and frustration.
Absolutely. And when you encounter those strange network issues, remember the steps we've discussed. Examine the IP address, check the server, verify the scope, and don't forget those physical connections or firewall issues.
It's all about being a network detective, gathering those clues, and methodically eliminating those possibilities.
And sometimes, honestly, the simplest solutions are the most effective. Just a good old-fashioned restart can really do wonders.
That's a really good point. Well, folks, we've reached the end of our deep dive today into DNS and DHCP. We have explored all the inner workings of these essential technologies, uncovered their secrets, and I think we've learned how to tackle some of those really perplexing troubleshooting challenges.
Absolutely.
Remember, knowledge is power, and with just a little bit of detective work, I think all of you can keep those networks humming along smoothly. So, until next time, happy networking.